Hello friends, welcome to Learner's Planet. Friends, this is third problem solving session for triangles and other polygons. In the previous two sessions of problem solving session, we discussed basic problems from almost all the concepts. In this session, we'll be taking more problems and the level of the problems will gradually go up, right? So get ready with your paper and pen and start solving the problems right with me. Okay. Now let's take the first problem. In the figure, ABCDE is a regular pentagon and ABF is an equilateral triangle. Find X. Okay, ABF an equilateral triangle. That means this angle must be 60 degree. This must be 60 and this must be 60. Now, if ABF is an equilateral triangle, then this side is equal to this side. Right, and since ABCDE is a regular pentagon, so if AB is equal to BF, then BF will be equal to BC. Right, now each angle of a regular pentagon is of 108 degree. So if it is 60, it has to be 48. Now this side is equal to this side, so from 180, if we deduct 48, we'll be getting 132, right? So 132 and BC is equal to BF, so each angle will be half of 132. I can say this is 66 and this is 66. The same logic we will apply over here, so we'll get 66 over here also. Now this total center angle should be 360 degree. So the value of X will be 360 minus 60 minus 66 into 2. Okay. So it is 300 minus 132. So it is 168. Okay. Nice. I hope you are clear. In the figure, ABCD is a regular pentagon and ABF is an equilateral triangle. Find theta. Okay. Interesting problem. Since ABCDE is a regular pentagon, this angle must be 108 degree. 108. Okay. Now BA is equal to BC because it's a regular pentagon, and in triangle ABC, sum of this and this should be 72. So it has to be 36. It should be 36. Okay. Now in this triangle ABC, this is 60 degree. Now since ABF, it is an equilateral triangle, so it should also be 60 degree. So if this portion is 36, this must be 24, right? Now in triangle A, suppose this is point P, APF, like this. This angle is 24, this angle is 60, so the third angle will be 180 minus 84. So it is 96, right? So this angle is 96, precisely this angle is 96, and this angle, that is theta, these two are vertically opposite angles. So if it is 96, it has to be 96. Pretty simple. This problem, in the figure, ABCD is a parallelogram. PDC, PQRS, ABS are straight lines. AQ, QD, BR, RC given. We have to find out the ratio PQ, QR, RS. Okay, I have drawn this diagram once again and bit bigger. So here A, B, C, D, P, Q, R and S. Now let's write the dimensions. If A, and then this line is parallel to this line and this line is parallel to this line. AQ is equal to 4, QD is equal to 2, BR is equal to 3, RC is equal to 3. Okay, so we have to find out PQ is to QR is to RS. PQ, QR and RS. Precisely we have to find out PS, breakup of PS. Now Triangle SBR and triangle SAQ, they will be similar. I have already explained this sort of problems a lot many times. SBR and SAQ will be similar, right? So whatever is the ratio of BR and AQ is there, the same will be ratio of SR and SQ will be there, right? So this is 3, this is 4. So SR, or I just write it over here, SR by SQ is equal to SR, that is here BR by AQ. Now BR is 3, AQ is 4. So SR, SQ, they will be in the same ratio, that is 3:4. The ratio will be same, but we cannot say that the values will also be 3:4. So I assume SR to be 3K and SQ to be 4K. So SQ is 4K, SR is 3K, that means RQ is K. Okay. Now if we see triangle PRC, triangle PQD is similar to triangle PRC for the same reason. This angle is common, QD is parallel to RC, so we can apply Thales theorem. PQ by QR, as suppose PQ is X, so X by QR, QR is K, so X by K is equal to 2 by 3. I'm sorry, the triangles will be similar. So X upon X plus K is equal to 2 by 3, right? The sides will be in proportion. So X upon X plus K is 2 by 3. So what I can do is X plus K by X is equal to 2 by 3, or 1 plus K by X is equal to 2 by 3. I'm sorry, 3 by 2. X plus K by X, it is 3 by 2. So 1 plus K by X is 3 by 2. So K by X is equal to 3 by 2 minus 1, that is 1 upon 2. Okay. So I can say X is equal to 2K. Right. Now we want the ratio X is to K is to 3K. So X is equal to 2K. So this is 2K, this is K, and this is 3K. So the ratio is 2:1:3. Okay, so concept of similar triangle has been used over here very beautifully and in very interesting manner. I hope you are clear. Now in the figure ABCD is a rectangle, CDE is a straight line, CDE straight line, AE is parallel to BD, AE is parallel to BD. If the area of ABCD is 24 and F is a point on BC such that BF FC is 3:1, find the area of triangle DEF. DEF. Okay, seems to be complicated. Let's try. The first thing is CDE is a straight line, and this line is parallel to this line, that is BD is parallel to AE, and since this is a straight line, ABDE should be a parallelogram, right? Now if it is a parallelogram, then AB will be equal to ED. Okay. Now the next concept we'll be using is, here it is X and this is also X. BF is to FC is 3:1. So I assume this to be 3K and this to be K, right? So the total length is 4K and this is X. So 4KX is equal to area of this rectangle, that is 24. So Kx is equal to 6. Now how can we find out the area of triangle DEF? Now if you have area of triangle EFC, from this if you deduct area of DFC, you'll be able to get the area of DEF. Area in all these three cases I'm talking about area. So from this triangle, if you deduct this triangle, you'll be getting the area of DEF, right? Now EFC, this is a right angle triangle. So this is K and this is X and this is X, right? So the total height is 2X, base is X. so area will be base is k, so half into 2x into k, that is kx. That means area of this triangle EFC is kx. Kx is nothing but 6, so I write 6 over here, minus area of triangle DFC. DFC. Now this is x, this is k, so it is half kx. Area is, so kx is 6, so half kx will be 3. So 6 minus 3, the area of DEF will be 3. So quite an interesting problem. Must try. Now in the figure, find the area of pentagon ABCDE. Now we can see this is 4, this is 4, this is 4, and we join B and E. Now since in triangle ABE this angle is 90 degree, these two angles are equal, so they must be 45, 45. Okay. Now precisely this pentagon is a combination of this square and this triangle. So area of square will be 4 square, that's 16, and area of this isosceles triangle that we have to find out. So if this length is 4 and this is x and this is x, that means x square plus x square is equal to 16. 2x square is equal to 16, x square is equal to 8, x is equal to 2 root 2, right? So this is 2 root 2, this is 2 root 2. So half base into altitude is that we can calculate, half of x square is equal to 8, so that is 4. So area of this triangle is also 4. So 16 and plus 4, 20. Now in the figure AB is equal to BC is equal to CA is equal to CD, then find angle CBD. Okay, AB is equal to BC is equal to CA, that means ABC is an equilateral triangle. So this is 60 degree, this is 60 degree, and this complete angle is 60 degree. Okay, now CA is equal to CD. So CA is equal to CD. So in triangle CAD, if this is 50 degree, it has to be 50 degree. Okay. Now in triangle ACD, this is 50 degree, this is 50 degree. So total is it is 100. So it must be 80 degree. Okay. Now in triangle CBD, CB is equal to CD. CB is equal to CD, and this angle is 140 degree. So this plus this plus this must be 40 degree. Since both of them are equal, each one of them should be 20 degree. Okay. In the figure, ABCD is a rectangle. M is the midpoint of BC and AC intersect MD at N. Area of NCD is to area of ABMN. It's not triangle, a quadrilateral. ABMN and NCD. That means area of this region and area of this region. Okay, let's start. First thing, M is the midpoint of BC, right? So this is suppose X. Now if it is X, it has to be 2X. Okay. Now triangle MNC and A and D, both of them are similar to each other. Concept we have discussed so many times. So if they are similar to each other, their area ratio will be 1:2, 1:4. Okay, because side ratio is 1:2, that means area ratio will be 1/4. Now what I do is that is a line passing through N. Now whatever is the, see this triangle is similar to this triangle, so altitude will also be in the same ratio. So if it is 2L, it has to be L. So the total length is 3L. Okay. Now we find area of NCD. Area of NCD. So from DMC, if we deduct M and C, we can get D and C, right? So DMC, it is 3L into X, half of 3L into X. That is area of MDC. From that I deduct area of MNC. That is half base into altitude. Okay, so it is 3 by 2 Lx and it is 1 by 2 Lx. So precisely it is Lx. Okay, so area of NCD is Lx. Similarly, to be able to find out the area of ABMN, what I can do is I can take area of ABC, triangle ABC, that is 3L into 2x, half of 3L into 2x. From that I deduct area of MNC, that is half XL. This is half, sorry. So it is 3 2s are 6 Lx minus, so that is 5 by 2 Lx, right? Now we have to find out a ratio. So it is Lx upon 5 by 2, or precisely 2:5. Okay, so very interesting question. In the figure, a square of side x centimeter is cut into 9 equal squares. If the total perimeter of 9 squares is 72 more than perimeter of the original square, then x is equal to. Now that's a simple question. Perimeter of this is 4x. Okay, being a square, and see, each side is cut into 3 equal pieces. So this is, the total is x, so each side will be x by 3. So perimeter of each square will be x by 3 into 4. So perimeter of all 9 must be this into 9, right? And if the total perimeter of the 9 small square is 72 more than this, so this is, difference is 72. So 12x minus 4x, 8x is equal to 72. So x is equal to 9. Pretty simple. The figure shows a trapezium of area 6 cm square. Find x. Okay, here x, the base is also x and altitude is also x. And what is the formula for area of trapezium? That is half sum of parallel sides, that is x plus 1, into altitude, that is x, and that is actually 6 over here. So x into x plus 1 is equal to 6 into 2, that is 12. So x plus 1 is equal to 12. So instead of solving the equation, write this as 3 into 4, right? These are two consecutive numbers, these are two consecutive numbers, that means x is equal to 3. Okay, now that's an interesting question. In the figure, ABCD is a rectangle formed by 4 squares each of area 1. DB is diagonal. Find the area of the shaded region. Okay, now we know, I just assume this point to be P and this is Q. Now PQDC, it's a square, and from this square, if we deduct the area of this triangle, I suppose this is X, QXD, we will be able to get the area of the shaded region, right? Now how do we find out the area of triangle QST? Now triangle DXQ and triangle DBA, they are similar to each other, right? Now this is 1, this is 1, 1, 1, 1. Now DQ is 1/4 of DA. DQ is, or we can say DQ by DA is 1/4. So since the triangles are similar, this and this, they should also be in the ratio 1:4. So x by 1 is equal to 1:4, right? Because this is 1, so x is equal to 1/4. Okay, now this triangle, in this triangle x is 1/4, this is 1, so we can find out the area half base, that is 1 by 4, this into altitude. So that is actually 1 by 8, right? 1 by 8 centimeter square. So the entire triangle is 1 centimeter square. So from that we deduct 1 by 8. So we get 7 by 8 centimeter square. Okay. So very interesting application of similar triangles. ABCD is a parallelogram. Find angle BDE. BDE. Okay, in this parallelogram we have to find out angle BDE. Now this side is equal to this side and this angle is given to us as 40 degrees. So remaining 140 to be distributed equally, this must be 70 and this must be 70. Now in parallelogram the opposite angles are equal. So this is 70, this should also be 70. Now this side is equal to this side, so if it is 70 it has to be 70. So this is 70, this is 70, that means this has to be 40 degree. Okay. Now this is 70, that means it has to be 110. Next is, since DC is parallel to AB, these sum of this and this should be 180, right? So if it is 70, it is 70, that it has to be 40. Then 40 plus 70 plus 70 will be 180. Now this is 110, this is 40, that means it is 150, that means this must be 30 degree. Pretty simple. So you might have observed that angle finding problems are really very easy. You start the problem, whatever is the information available with you, you start with that and apply the properties of quadrilateral and triangle, isosceles triangle and equilateral triangle. Finally, you will definitely get the answer. Okay. Now this problem. In the figure, ABCD is a parallelogram. E and F are points on AD and BC respectively. AB is parallel to EF. EF meets AC at G, okay, and AG is to GC is 1:2. Area of ABFG and area of EGCD is, okay. The first thing is when you see these sort of triangles, just try to recall similar triangles. Now triangle AGE will be similar to FGC, right? Since their sides are in the ratio AG is to GC, that is AG is to GC 1:2 ratio, that means area will be in the ratio 1:4. So I assume this side to be maybe X. This is X, then this must be 2X because this will be X, okay. As ratio of this to this is 1:2, that means all the remaining sides will also be in the same ratios, right? So this side and this side, they will also be in the same ratio 1:2. So if it is X, it has to be 2X. Now if it is X, BF will also be X. So the total length over here is 3X. Now I assume the area of AGE to be A, then area of FGC will be 4A. Side ratio is 1:2, that means area ratio will be 1:4. Now see triangle CGF and triangle CAB. Now triangle CGF is similar to triangle CAB, right? If the two triangles are similar, their area will be once again in the ratio of their square of their sides. So CGF side is 2X, so 4X square, by CBA side is 3X, so it is 9X square is equal to area of CGF, that is 4A, by area of CBA, that is I assume to be say K, okay. That means K is equal to 9A, right? That means area of CBA is 9A. So if it is 4A, it has to be 5A, right? The total area of ABC, triangle ABC, is 9A. If this is 4A, this has to be 5A, okay. So we got ABFG, right? ABFG, that is this part. The total area of triangle ABC is 9A. From that If I deduct 4a, that is area of FGC, that is 4a, so I'll get 5a. Now triangle ABC and ACD, this diagonal divides the parallelogram into two equal triangles. So if this area of this triangle is 9a, area of this triangle will also be 9a, right? But we want area of GEDC, right? EGCD. So area of ACD is 9a. From that, if we deduct area of AGE, we will be able to get area of EGCD. So from 9a, if I deduct a, I'll be getting 8a, right? So area of ABFG, area of EGCD is 5:8. A very good, interesting application of similar triangles. If the explanation is not clear for the first time, then do watch it once again, because that's really very important concept, important problem, you can say, we have discussed over here. Friends, so many questions we have discussed in this session. In the next session, we'll be taking more problems, and you might have observed that almost every question includes the concept of similar triangle, right? And all these questions are from this examination papers, right? Previous year papers. So, you know, good number of questions from similar triangle are frequently asked in competitive exams. So your concept of this topic must be very clear. Okay, so I'll see you in the next session once again. Do revise this session and the previous ones. Bye bye.